Hi everyone. We are Team Orchestration Scripting Environments, and we're here to talk through our problem statement and our conceptual and practical approach with you. In terms of our problem statement, we're looking at the challenge where it's difficult and time-consuming for mentors to understand and write scripts to support a mentee's ill-structured problems, meaning complex problems that arise in networked workspaces. This is enlarged because there's an abstraction barrier between human thinking and machine representation. Specifically, it's difficult and time consuming because for a given situation, there are many potential causes, there are constant changes, and there's a conflict between the non-deterministic nature of an ill-structured problem and the deterministic nature of computer programs. In terms of our conceptual approach, we wanted to address these obstacles through our orchestration scripting environment, which you will see in a minute, by prompting mentors to formulate hypotheses about root causes for a given situation, prompt context awareness for diagnosing key root causes, and provide context-specific mixed initiative support.
And our conceptual approach unfolds in this interface that we have created. I will walk you through the interface with an example of an imbalance in the distribution of DTR work among students. So the interface is divided into three parts. It's a scaffolding guide, a step guide that explains the structure of a script, and a block view workspace where the mentor actually construct their script. So the scaffolding guide first asks the mentor to describe the situation that they want to script for. Right here, we're using the example of an imbalance in the distribution of design and tech work among students. The scaffolding guide then asks the mentor to list possible root causes that they think might be causing this situation based on their understanding of their students. So in this case, maybe the student is avoiding doing tech or design. Another root cause might be students are not slicing, because one story usually should include both design and tech components. But if one story only contains design and T, that might be what's leading to the imbalance in the distribution of DNT work, design and tech work. And then in step 3, the mentor is asked to formulate a help strategy for the potential causes identified in step 2. So if the student is avoiding doing tech or design, the mentor would want them to refocus on the riskiest risk, walk through reflection process, and diagnose reasons for avoidance. If a student is not slicing, then the mentor would help the student recognize the stories should be around a new understanding instead of around design or tech categories. After they're done with the scaffolding guide, they will move on to the step guide, which first explains our current execution flow in our system. So when the detector for an imbalance in the distribution of design and tech work triggers, the system will send a message to the mentor that provides suggestions for root causes and context information to help mentor diagnose the cause of the problem. Then the mentor, based on the information in this message, and their understanding, of course, would select a root cause by replying to that message. And then the system would execute the strategy for the root cause selected. The step guide then explains the structure of the general structure of a script, which consists of scope detector, a message constructor, and strategies. So right here, the mentor wants the script to apply to all projects. Just drag in an all project block over here, and we'll then move on to the detector. So here we're comparing student 1 and student 2's points spent on tech. So we use a compare block, and we can also set how big of an imbalance we think is worth addressing. So for example, if student 1's points spent on tech is 3 points larger than student 2's points spent on tech, this signals a significant imbalance. We can do this similarly for design, and that would be the detector for this situation. So after this detector triggers, the system goes on to send a custom message to the mentor, which says, hey, look like your detector for design and tech imbalance has been triggered. This is what triggered it. The mentor can use the specific data points that have triggered the detector to help themselves better understand what's going on. The message then says, here are the potential root causes that you have identified, which is exactly what they put over here. It then goes on to provide some context information to better understand the RCs. So for example, since we're dealing with points committed in the sprint log, it might help to look at the summary of the task in the sprint log. And the context information is distinctive to each of these RCs are as such. These are the context informations that will help mentors diagnose specific root causes. So these are signals that are distinctive to each of these, to each of the root causes. For example, in this case, we can show the DTR makeup of each of the stories to see if they contain both design and tech. The mentor can also use this space as a memo for themselves. For example, remind me to look at students' metacognitive barriers. And the message would ask the mentor to respond, which root cause do you think is causing the above problem? It will go on and execute these strategies that the mentor set in the strategy part. I'm not going to fill out the rest of the strategy, but the idea is to provide context-specific support at specific venues and times that are that best suit the mentor and mentee's workflow. And after the mentor have created the above script, on the system side, it will compile to a script that looks like this, which is partly orchestration script, partly the customized message, and the strategies that will be enacted in the agent.
In terms of our evaluation methods, we have conducted 3 major rounds of user testing alongside like smaller formative user tests. In terms of for our user test number 1, the goal that, or like the first user test that we conducted, the goal of it was really to look at the usability of our interface. Is our interface usable? And given a situation, will users be able to find different blocks, understand what they did, and use them properly to help us to build a script that would execute as intended for the situation? And another thing that we were observing for was how does the user get to decide on what blocks they need to bring this script to life? So we use it on 3 DTR students who are technically mentees, not mentors in this situation. And we also conducted self-tests to ensure that they align with basic usability heuristics, like our interface aligns with basic usability heuristics. We gave on the, oh, can you
Sorry.
go back?
How do I go back?
Yes, here you go. So we gave the students the pseudocode on the left side, on the right side, as you can see, for 2 different scenarios, and we just observed them as they scripted or used the interface to script for it. Our measures included number of blocks used as intended versus number of blocks not used as intended, and blocks or parts of the interaction when users expressed or said quotes like, "I don't really know what this does or means." So that's for our test number 1. In terms of our test number 2, the goal for this test was, given a situation, will the mentor be able to identify accurate root causes and map them to applicable strategies? This was the first test that we were looking at our conceptual technique or approach for scaffolding like helping the user scaffold through like identifying root causes and mapping strategies to them. So that was the phase before, like the phase of the, or like the current version of the interface that you saw with Grace. We tested this with 1 mentor plus their mentee, and we used this low fidelity prototype on the right. The main measures that we were looking at were the number of root causes that the mentor identifies And we also interviewed the mentee to check if the root causes the mentor identified were accurate. For our third test, the goal was given a complex scenario, just like the one Grace walked through, a scenario that has multiple root causes and could potentially have multiple strategies based on the situation and the student, etc. Is the user able to identify root causes and map them to strategies using the scaffolding interface they have? And are they able to express what they wrote about in the scaffolding steps using blocks? Why or why not? So we used the interface that you saw with Grace. We tested with 4 DTR mentors, and the main measures that we were looking at were number of root causes identified. We were hoping for the mentors to identify at least 2, and the number of strategies. We were also hoping that the mentors would identify at least 2. We compared the script they built with the script we built, or like the happy path, where like we know the script would execute as intended. And we compared like and measured how much they got right, or how much how much of the script they wrote would actually translate into what they intended on the back end, and what parts would break, and took note of those.
So these are some key findings from our user tests. Compared to the old interface, mentors produced scripts that accounted for different potential root causes that included different tailored strategies. This reflects a fuller and deeper understanding of the problems at hand. And in a real world user test where we checked the root causes the mentors came up with against the actual root cause that was causing students to struggle, the mentor was able to diagnose the accurate root cause, which reflects a good understanding of potential reasons behind a student's struggle. So we were able to conclude that OSE was able to prompt mentors to formulate effective hypotheses about root causes. We also observed more effort towards a better grasp of the context of the problem. Mentors said, I would want to ask my students further about this root cause, which reflects that our tool is promoting more conversation with students to understand the causes of the problem, which is very desirable in a ill-structured workspace. Mentors also expressed need for context to bridge the root causes and the strategies. One mentor said, if you give me enough context, I can have hypothesis. Mentors were also prompted to evaluate and leverage limited data about the root causes to understand the situation. One mentor added a memo to himself in the custom message to remind himself to evaluate the data, which reflects an increase in context awareness for diagnosing key root causes. Since in our user test, we didn't focus too much on the strategy part of the script, the mixed initiative support design argument is still work in progress. One surprising thing that we also noticed was an improved usability. So in the usability test, users with no prior experience with the Studio API or the OS language were able to create scripts that script correctly by following the step guide that would execute in the backend with no issue. Users were also able to understand what most of the blocks do just by looking at them, which reflects that the blocks designs are intuitive and reflects mentors' natural way of thinking.
All right, overall, prompting the mentor to scaffold through reflecting on root causes and how to diagnose them, as we saw, helps in creating context-aware scripts that embody a richer understanding of the problem at hand. In terms of limitations that we came across, we found that it's time-consuming to learn and use our conceptual approach and like our practical model, which is our interface for this complex situations. And we are also still unsure about the practical value of this process, as we haven't really seen like them or observed the mentors and use it with the mentees over a longer period of time. In terms of future work to address limitations, tying to my last point is a longer user study involving both mentors and mentees to observe scripts unfold, like scripts as they unfold over time. Designing to facilitate learning. For example, like having a components repo or something that mentors can build upon, since in a given like community you'll have like multiple situations that are repetitive, or maybe mentors, like we found that mentors had like an easier time scripting when they had something to build upon. So this would be something interesting to explore. And the last thing is a debugging feature to enable users to mitigate errors and also preview what the script would do, like when it runs before actually running it. But yeah, other than that, that's everything for this quarter. Thank you so much for your time.
Thank you so much.